Hey everyone, and welcome to this Forge College Explainer. First off, I want to say a massive congratulations to all of you. You just wrapped up the capstone build, assemble, test, and document the final program lesson, and honestly, that's no small feat. But as we pivot from building those advanced Solana program structures to actually making them talk to the outside world, we really need to tackle a hidden yet absolutely crucial pain point, and that is data translation on Solana. I mean, really think about it for a second. You've spent all this time agonizing over account data layouts, tinkering with program-derived addresses, and meticulously calculating rent exemption and account sizing. But how does a Solana program, or even an off-chain client, actually know what the raw bytes sitting inside those carefully sized accounts mean? How do we absolutely guarantee that what we write to memory is exactly what we read back?
Okay, let's look at our agenda for today. 1. Connecting the dots. 2. Packaging and translation. 3. The user profile example. 4. The format showdown. And 5. Final takeaways.
Let's jump right into Section 1, Connecting the Dots, from memory to bytes. So when you were deciding on field order and padding expectations in the last few modules, you were actually, implicitly, relying on a solid serialization strategy without even knowing it. Formally, serialization is what converts your in-memory program state into a portable sequence of bytes, and then back again. And the absolutely vital thing here is that this mapping must be perfectly reversible. It is an exact science. If the on-chain byte layout is even slightly ambiguous, your deserialization code could spit out completely different values depending on the client library you happen to be using. And in Web3, ambiguity literally means absolute chaos.
Moving on to Section 2, Packaging and Translation, the international shipping model.
To really wrap our heads around serialization, I want us to use a specific mental model. We're going to treat data serialization exactly like packing a suitcase for an international trip. So on the packaging side of things, this is where we arrange our fields into a tight, predictable layout. It's kind of like picking the absolute perfect compartment for every single item in your luggage, placing things in a very specific order so whoever opens it can find them without guessing. Then you have translation. This is converting our typed values, integers, strings, things like that, into a compact binary form. It's basically making sure all the labels on your packaged items are written in a language the customs officers at your destination can actually read. Because imagine what happens when packers use different standards. Say one person packing the crate uses inches, and the person unpacking it uses centimeters. What's going to happen? I mean, best case scenario, you get some highly confused baggage handlers. Worst case, and this is what happens on Solana, your program violently crashes and your on-chain state is completely corrupted. We absolutely have to share the same packing rules. No exceptions.
All right, Section 3, the user profile example. Let's bring this analogy down to earth.
Let's look at a real-world example of serializing a program account struct on Solana. Picture a program that stores a user profile. It might look something like this. We've got a 64-bit unsigned integer for the user ID, a Boolean flag for whether they're active, a string for their username, and a vector of recent transaction hashes, say 32 bytes each. Making the call on exactly how these fields are ordered, choosing little endian for integers, and pinning down our length prefixes for the string and the vector, that is us finalizing our packing strategy. If you put that user ID first, for example, you get a stable, predictable offset for lightning-fast reads. Now, once the packing is done, we have to unpack, and that requires an extreme level of care. Step 1, check the offset. Step 2, read the length prefix. Step 3, validate those bounds before you do any memory allocation. These validation checks, they act just like strict customs inspections. If a client tries to tell your program that a username string is, 10,000 bytes long, you need to check if that actually fits in the remaining buffer before you allocate the memory. This is what stops out-of-bounds reads, malformed inputs, and massive security vulnerabilities in their tracks. Section 4, the format showdown. Binary versus textual formats. So we know how to pack, but what materials should we use so we aren't wasting precious space and money? Just look at JSON up there. Using JSON for on-chain storage is literally like shipping a single pair of socks inside a giant refrigerator box. It's incredibly verbose text, meaning terrible compactness. And on Solana, where the size of your account dictates your rent costs, well, that's just financially ruinous. Protocol buffers is pretty great, sure, but relying on tags and optional fields introduces ambiguity. And then at the bottom, we have Borsh. Borsh is the ultimate hyper-efficient shipping container. High determinism and exceptionally good compactness. To quote basically every strict, slightly eccentric chief engineer I've ever had the pleasure of working with, determinism is not optional. You must have predictable offsets. Without a deterministic guarantee, a client written in Rust and one written in JavaScript could look at the exact same sequence of bytes, disagree entirely about where the field boundaries are, and produce completely divergent views of your account data. And honestly, this is exactly why Borsh is so incredibly popular in the Solana ecosystem. Borsh avoids runtime tags entirely. It relies strictly on explicit field ordering to keep overhead to an absolute minimum. Now, yeah, Borsh does sacrifice some of that flexible backward compatibility magic you get with other formats, but in return, it gives you fast, predictable, and remarkably cheap on-chain storage. When you are paying gas and rent by the byte, that is exactly the trade-off you want to make. Finally, Section 5, Final Takeaways. Preparing for Borsh Rules. Okay, let's wrap this up. Your key takeaways. First, serialization is a strict reversible contract between your in-memory types and the bytes on disk. Second, compact binary formats like Borsh save you serious rent and transaction costs. Third, strict validation during deserialization is your best shield against malformed data. Up next in this course is the core principles of Borsh lesson, where you'll see how all these concepts actually play out in code. But before you go, I want to leave you with a thought. If Borsh intentionally sacrifices flexible backwards compatibility for raw speed and low cost, how are you going to handle upgrading your smart contracts when your data structures inevitably have to change down the line? Chew on that. Make sure to visit forge.college to dive deeper into the subject and explore a ton of other awesome Web3 topics. Thanks for learning with Forge College, and I will catch you in the next explainer.